plug in?
Yes. So when I plug in 1 over x, when I plug in 0, I didn't copy the whole thing. It was from the right. I don't know if I said, but it is from the right. Okay. Good. So when we plug in 0 from the right in 1 over x, does anyone remember?
Would you just plug in a very small number close to 0?
Yes, but based on the graph. I said a long time ago, it seems like a long time ago, that the graph of this has to be remembered by heart forever.
Will it go to infinity?
It will absolutely go to infinity. Very good. Now, what about natural log? When x approaches 0 from the right, where will that go? Ian?
What was the question?
As x approaches 0 from the right, where does natural log go? This is another graph that has to be embedded in our memory.
Go towards 0.
No.
I think it also goes to negative infinity.
Very good. Negative infinity with minus in front, where will that go?
It flips it to positive.
Very good. How much is infinity plus infinity?
Infinity.
Infinity. What does this mean? When a limit
There's going to be a vertical asymptote there.
at 0. Very good. Great job. Any questions?
Professor, can you just plug this into your calculator and get it from there, or do you want us to write it out?
Okay. Never use calculator before you think. Use calculator to check. Credit is not given for calculator answer. Thank you very much. Thank you very much. I would have probably forgotten to say this. I'll probably have to say it more than once. Everyone can punch in. I can punch in, I can plug in the function and punch in numbers. Anyone can do that. I want to teach you how to think. You can learn the calculator from me too. I'm sure you know more about the calculator than I do. Okay, very good. So we're moving on to 2.3, and that deals with limit laws. So limit laws are like rules that we have to use whenever we think or calculate limits. And we have something very important, but I cannot present it yet because we don't have all the concepts we need. But let's start. There are 11, 12 different limits. I would myself reduce them to fewer, but since your book presents this, I'm going to list them. So first of all, assumption. The assumption is extremely important. This is something that is like you cannot drive a car if it doesn't have an engine unless you push it, right? So the assumption has to be checked at all times. Without the assumption, the limit laws fail. And here's the assumption, that the limit of a function f of x as x approaches a from either side exists. And let's say we give it a name. This number is L, but it's a number, it's a fixed number. And let's also assume that g of x, limit I meant to write, limit as x approaches a from either side of g of x is m. So this is our assumption. If these two limits don't exist, this is 5 and this is 10, or this is 11 and this is -5, the limit laws fail. Okay, so let's start with the first one. First limit law, number one, is the limit. I like to put 1 and 2 together, not because I'm lazy, it's because they are pretty similar. And addition, if I should say the subtraction is a opposite addition. So 1 and 2 together, limit of f of x plus g of x as x approaches a from either side is limit of f of x as x approaches a plus limit of g of x as x approaches a, because the limits exist, and this is L plus m. And yes, if I have here minus, I will have here minus, and I will have here minus. So that's why I like to put these two together. So if the two limits exist, then I can write this. A minute ago, we were looking at this limit. Allow me to copy it. Limit as x approaches 0, 0 from the right of 1 over x minus natural log x. And I'm asking you, can I write limit as x approaches 0 from the right of 1 over x minus limit of natural log x as x approaches 0 from the right? Gia?
Yes.
Derek?
I don't believe so, right?
Correct.
Because it's one function. That's all one function.
No. It's because the limit of the first function is not a number, and the limit of the second function is not a number. The assumptions fail. The limit of this is infinity, and the limit of this I don't even care what it is, but even that one does not exist. So this is D and E, and this is D and E. So the limit of a sum or difference can be changed into a sum or difference of limits only if the two limits are numbers. They're not. So I cannot use the limit law in this case. Is everyone in agreement?
Yes.
Perfect. Okay, very good. Number 3. The limit of a constant times f of x as x approaches a. Common sense, c goes in front because it's a factor. So it's c multiplied by limit of f of x as x approaches a. And limit number 4, limit law number 4. The product now. Limit of f of x multiplied by g of x as x approaches a from either side. Common sense, what do you think this will be?
Would be L times M.
So it will be correct. So it will be limit of f of x multiplied by limit of g of x. That's our first step. And yes, it is L times M. Perfect. We had a limit a minute ago, which was a product of a function 1 over x and another function secant x. 1 over x, secant x. So with your permission, I'm going to copy it again. Would you allow me to write this according to the limit law? Gabriel?
I'm not sure.
Can you follow? Is this okay, or?
Yeah, okay, so wait, like, so it's like neither of them can go to infinity for it to meet the assumption, right?
So the assumption says that the limit of the first function has to be a number, and the limit of the second function has to be the same number or a different number, we don't care, but it has to be a number.
Okay, then yes.
Okay, Trey, I see you're with us now.
It wouldn't be able to since 1 over x is infinity.
Exactly. This is D and E. Some sort of positive or negative infinity, we don't care, it's not a number. And the same thing with this one, not a number. The assumptions are not fulfilled. So I'm not sure which part is not clear. I was hoping for better answers. Is this clear what I'm saying, or is it's not?
That's clear.
Okay, now the ratio. Limit of f of x over g of x as x approaches a from either side is limit of f of x divided by limit of g of x as x approaches a. And this is, Jordan, how much?
It would be L divided by M.
Very good. And I'm going to put an if. And Oscar, why do you think I put an if in there?
Make sure that the bottom is not 0.
Great job. So the limit of g of x as x approaches a cannot be 0. In other words, m cannot be 0. Of course. It will make no sense. It will be undefined. Okay, we are on limit 6. Any questions? Anyone? Any questions? Okay, the limit of a constant as x approaches a. What do you think? Nabiha, what do you think?
It would just be the constant.
Absolutely. Number 7, limit as x approaches a. And now we're going to look at some powers of f of x raised to power n. And before you say anything, I just need to clarify, because this is a very important topic. It's called swapping operators. This is a theorem. We are not there yet. I'm not interested in you remembering the theorem, but at least in the long run, but remembering what swapping operators means, and when. When is this allowed? And the question is, what operators am I trying to swap? This is an operator. It's a power of a function. Remember, examples of operators. Or let me put a function in here. That's even better for you to see. Operator applied to a function. Operator applied to a function. Operator applied to a function. So natural log is an operator. It does something to a function. The nth root, it does something to a function. Power n does something else, a different operation to the function. So this is an operator. We know this from last time. And this is an operator. I am going to swap the operator, the orders of the operators. As you see, here the function has to be raised to the nth power. This is the first operator. When I'm done, I apply the second operator. Now I want to swap them and apply them in the opposite order. I am allowed to do that. When? This is very important. We haven't gotten there yet, but I need to use it now, and I want you to understand the process because I need to use it later. When? Only under conditions of continuity. Later. So only on the conditions of continuity, I can swap the operators. I can put this operator to touch the function because now this operator touches the function. Now I will bring this operator to touch the function and this operator to be outside. And this is what we're going to do. So limit of f of x as x approaches a. Okay, so now this is on the side. Okay, can anyone give us the inside? What is this equal to? Carson, would you like to tell us what is this equal to?
I'm not sure.
What is the limit of f of x as x approaches a?
Is it just L then?
Very good.
Oh, okay.
So L to power n. So this was obtained using the theorem that allows us, under certain conditions of continuity, to swap the operators. The operator that was touching the function is no longer touching the function, is outside. And the operator which was not touching the function is touching the function now, and it's the inside. So the inside became the outside, and the outside became the inside. Okay. Of course, n positive integer. Okay, moving on. I think this is 8. So we have limit of x to the nth power as x approaches a. Again, we have an outer operator, an inner operator, and an outer operator. I will swap under conditions of continuity. I will swap the operators and have this. So now you can say, wait a minute. Where is this connected to all this? Where is your f of x? Where is your g of x? True. So it's the same situation here. I didn't have f of x and g of x. So no, this is just a simple linear function, the y equals x. So we have to apply the inside. And can anyone remind us, how do we find limits? What do we have to do first? Kush, what do we have to do first?
You define a limit.
Yes.
Do we follow x to a?
Yes. So we have to plug it in. So limit of x when x approaches a will equal how much?
You said the limit x, how much?
The limit of x when x approaches a. How much?
Over x?
How much will it be?
A over n?
You mean a to power n? Correct. Very good. Awesome. Number 9. Okay, we have limit as x approaches a from, of course, the nth root. We can make it first of f of x and then n root of x. Okay, so can anyone tell us what we should write? Again, this is an operator. It touches the function, so it's the inner operator, and this is the outer operator. So under conditions of continuity, what do you think I'm going to write? Anyone?
So would you write the n the power root limit f of x?
Very good. As x approaches a, and of course n has to be a positive integer. And of course, if n is even, then f of x has to be greater than or equal to 0. So can anyone give us the answer here?
Nth power, root
The,
over L.
yes, indeed. Very good.
Thank you. I'm sorry.
Yep, that's correct. Everything is fine. So the last one, which personally I don't consider special, like I don't consider this one special, but anyway, so it's in your book, so let's continue with that. So the nth root of x, same conditions, n has to be a positive integer. If n is even, then x has to be greater than or equal to 0. Can anyone give us this answer? Isaac?
It would be m root the limit of x.
Okay, very good. That's the first step. Okay, excellent. And then?
M root a.
The nth root of a. Great job. Okay, so now let's practice these limit laws. And if you'd like to go back, let's go back to the book.
Professor, I had a quick question.
Sure, anything.
For when you put that n has to be